I mean, look at your homework and you see what we're doing. It's all not a homework, not web work. Which one? Which one?
I don't know how to plug in the fraction.
Why?
But that's a good way to study within a group though, because we all have different problems. It's kind of similar problems, just different numbers. Right. They are very similar, just different numbers. Oh, yeah. Same concept.
I thought it was all the same numbers. I didn't even know. Y'all letting me know.
This thing doesn't.
No, he did it on purpose. He did it
I
on
does
purpose.
the only thing I do is I look at the questions and I delete
That's
them.
a Christmas is coming. Okay.
Yo, speaking of Halloween, yo, look at the Instagram. Look at Instagram for Halloween with the daycare. That joint is fire. Yeah. Yeah. Not just that though. All the clubs they make like when they do club fair, like on the grass, like they make this massive thing and then they all just come around and trick or treat. That's fine. Yeah. Exactly. No? Mhm. Now look at it on Instagram. Look at it right here. Okay. So this was a question that was asked right here, right? So we got a plus b squared, right? All you do is just plug in the numbers and you just square it. So,
Which one is that? Oh.
mm, yeah, go ahead. Yeah. So this is going to be 1/5 plus -1 squared, right? So all we got to do is just add it and then we're done.
Real quick,
Hmm?
you put the parentheses and the negative and positive
Exactly, right?
together.
So we know that this is the same as what? 1/5 minus 1/1, right? Squared, of course, right? In order for me to subtract two fractions, they got to have the same denominator, right? So how do I make them get the same denominator here? What's the LCD here?
5.
Good. Right. So how do I get a 5? How do I change a 5 into a 5? I multiply it by what? By 1, right?
Yeah.
What I do to the top, I do the bottom, I gotta do the top. How do I change a 1 into a 5? Times 5, right? And what I do to the bottom, I gotta do to the top, right? So what does this become? This becomes 1 minus 5/5, bless you, squared. What's 1 minus 5? Close. -4, right? So this is -4/5 squared.
You
All
want
right.
another axis to simplify it for me?
Huh? No, you don't have to simplify this. You just got to finish it. So what's -4 squared,
Negative
right? Because remember, we're just gonna we square the top and we square the bottom, right?
8.
So what's -4 squared? Not 8. No, no.
I mean negatives, yeah.
Positive 16, right? And then what's 5 squared? 10. No. Give me a better answer. What is it? 25. And that's it. That's the answer. That's all that is. All right. So that was the a plus b squared. Go ahead. Huh? Yeah. With the exponent. Like how?
Oh, you know that already homework?
Yeah. You use the carrot. Maybe.
Putting it, you see how we put the bracket?
Yeah.
Yeah, so one of them should be X.
Yeah.
Why do they?
Which one? Like this one? Because it's the inside that I'm going twice. If you what? You like you want to write that out? Like you want the arrow? You want to write the arrow out?
When she puts in the homework,
Yeah.
that is what it does.
Yeah.
If it still counts, and the same as just putting the X.
Yeah. 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 I mean the question when you click submit, the question tells you if it's right or wrong. Yeah. Yeah. As long as it's green, you're good to go. Yeah. Right. Before you do the subtraction, then square. All right, so look, for a squared plus b squared, right? My a is what? 1/5 squared plus my b, which is what? -1 squared. Now you're squaring them individually, right? So 1/5 squared is what?
1/5 squared
Mhm.
is 1/5.
Yes, what's the answer? Right, so 1/25, right? Plus what's -1 squared?
One.
+1. Light work, right? I mean, you could go a little bit further, right? This is like 1/25 plus 1/1. And in order to add them, they gotta have the same what? All right. So how do I change a 1 into a 25? Right? Which use a bottom into the top. So this is literally 1 plus 25 over 25. That's it. That's the answer. Because the square cancels out the negative. That's why. Yeah. Mhm. That's what the parentheses is doing. Yeah. So now let's look at C. I'll change up the color for this, right? So A is what? 1/5 squared plus 2 times 1/5 times -1 plus -1 squared. All right. Let's go step by step. So
So the first one is 1/25
good.
plus,
Plus 2 times 1/5 times -1. What's -1 squared again? +1. Good. Now do your multiplication, right?
1/5 times negative.
The 1/5 times -1 times 2, which is what?
2 times 3 plus 1.
So it's like 2/1 times 1/5 times -1/1. Right? I know. So how do we multiply fractions? We go straight across, right? So what is 2 times 1 times -1?
1.
Is 2, and then 2 times -1 is, say it. All right, so we have -2 over what is 1 times 5? And what's 5 times 1? All right, that's it. Plus 1/1. All right? LCD. All right, so what's the LCD here?
5.
No, what's the LCD here? What's LCD? Mm-hmm. 25, right? So how do I make a 25 and a 25 times what? Times 1, which is the bottom, you do to the top. How do I make a 5 into a 25? Times 5. What I do to the bottom, I do to the top, right? And then how do I make a 1 into a 25? Times 25. What I do to the bottom, I do to the top, right? And that's it. So what does this become? This becomes 1 times 1 plus -2 times 5, right? Plus 1 times 25 all over 25, right? So let's simplify this down a little bit. 1 times 1 is -2 times 5 is -10. 1 times 25 is plus 25. All right, over 25. Now, what's 1 minus 10? -9. All right. So what is -9 plus 25?
Going back down.
Mhm. -9 plus 25. What we got? Say it again. 16, good. Right? So it's 16 over 25. And we're done. That's it. Questions on this?
I like this.
It was good? All right. They didn't tell me the number.
Real quick, go back to, let me show you.
Mhm.
Oh,
Oh,
you see the second one? Where's the second one?
the orange one?
No, go down. Over here, let's go down.
Okay.
You see this part right here, and you was like, okay, it's kind of like, I was thinking of the other stuff that goes 2 times 5 plus 1. What is that?
That's for the mixed number. Yeah. So,
But
but when you have like a whole number times a fraction, you can put the whole number over 1, and then just multiply straight across. Yeah,
Okay,
and then that's how you do that.
that's.
Mm-hmm.
Oh.
So we good?
Yeah.
Okay, go ahead. Yeah. So anytime you see a variable, right, you want to put it in parentheses, and then that implies it's going to be multiplied. It implies multiplication to another variable. Yeah.
What's the time?
Because they're being multiplied. Yeah. Right. 2 parentheses next to each other means that like this variable is being multiplied by this variable. Yeah. Like on the outside.
Yeah.
So then that means you're gonna do what's on the inside first, and then whatever's on the outside is gonna be multiplied by something else. Yeah.
And when you put it down,
Yeah.
change the sign.
Yeah.
Like if it was a plus, then on the next.
But your homework doesn't have anything that complicated though.
Yeah, but change the whole thing.
Yeah. No,
No,
the one that she was asking that was more complicated. Like it was like a parenthesis in a parenthesis kind of thing, like a nested kind of thing. Yeah. Yeah. No, but your homework doesn't have anything that hard. Yeah. Nah, it's simple. You just plug it in and that's it. Really? You know you can use your calculator, right? Y'all can use a formula sheet.
But, you know, the brain that way. That's a right.
Why?
I don't know how to plug in your fractions for you.
So look, 1 over 5 is open parentheses 1 divided by 5. That's a fraction.
Yeah, but that's how I do it, but it comes out a whole nother different number when I'm dividing.
Like you're dividing a fraction by a fraction or multiplying?
Like this probably,
Mhm.
divide, I did one, I divided 1 by 5. I'm fine.
So
And it only gives you 16. And it gives you that's so tiny.
it should have gave you 16 over 25. So here's how I would type this question in, right? So I'm looking at this part right here, right? I'm gonna change the color real quick. I'm gonna do it in blue, right? If I was typing it in your calculator, right? It would be open parentheses. Then I do another open parentheses, 1 divided by 5. And then you want to raise it to the second power. Then you're going to close parentheses plus 2, right? Then you could just, hold on one second, I got to go across. Open parentheses, 1 divided by 5, close parentheses, open parentheses, -1, right? Make sure you get that -1 in there, right? And then plus, then you're going to do open parentheses. Let me think for a second. Yeah, open parentheses, -1, close parentheses, raised to the second power, close parentheses. That would give you the answer. That's what happened when you don't get the new calculator. That's how the old ones were. Mhm.
So the one you did, you told us, yeah.
The new one. You have it already, I think, right? Little black, yeah. So you know how you have that button on there, the fraction button? She don't have that. So that's why she got to insert like this. That's 16 divided by 25. So there's a button on your calculator called F to D. It looks something like this, like F, and I think it might be something like that, and then D, right? If you press that, it give you the 16 over 25. You don't see it? Let me see. Hold on. I got you.
That's you.
Let me see. Let me see.
Not you.
Where's that damn FTP? This one, purple, right? So look, 16 divided by 25. That, right? So then you press second, and then you press this FTP, and then so
Okay.
you should still change the calculator though. Nah.
Dave Chappelle? That sounded.
Oh yeah, I remember. I remember that skit. Yeah, that's what
You know, it's crazy. They would go to the tape,
I.
and there was like a couple. For a while, they were like, I don't do it. Like, finally, somebody knows. Let's see how I
Yeah. Any other questions? Or are we good?
No, that last.
Yeah, good. All right. All right. So let's look at what we're getting into now. Yeah, we got time. We got mad time. So the homework for this is already posted. All right, so y'all can take a look at it if y'all want. It's really, really easy. I think it's like 10 questions, to be honest with you.
Which one?
This the topic that we're doing right now. All right. So 1.3 and 2.1, something like that. Like the stuff that was just posted like yesterday, that thing, right? So yeah, you see the date on there when you log in. Anyway, planning a statistical study. So planning a statistical study and gathering data are essential components of obtaining reliable information. Depending on the nature of the statistical study, a great deal of expertise and resources may be required during the planning stage. In this section, we will look at some of the basics of planning a statistical study. All right. So essentially, this is what y'all gonna basically be doing in your next statistics class. All right. At the 4-year school. All right. Or I forgot, we all going for our PhD, so in our graduate programs, right? Yeah. Everybody here going for their doctorate, right?
Just master's and then
Are you saying no? Nurse practitioner, man. Nah. Doctorate, man. All right, so this is the procedure on how to do it, right? So this is the basic guidelines for planning a statistical study. First, you want to identify the individuals or the objects of interest. 2, you want to specify the variables as well as the protocols for taking the measurements or making the observation. 3, you want to determine if you will use an entire population or a representative sample. If using a sample, decide on a viable sampling method, right, that we spoke about before. In your data collection plan, address issues of ethics, subject confidentiality, and privacy, right? That psychology stuff right here. You don't want like people's information going out, HIPAA, all that stuff, right? Yeah. So if you are collecting data at a business, store, college, or other institution, be sure to be courteous and to obtain permission as necessary. 5, collect the data. 6, use appropriate descriptive statistic methods, which we'll go over, and make decisions using appropriate inferential statistics methods, which we will go over later on. Finally, note any concerns you might have about your data collection methods and list any recommendations for future studies. That's it. Questions on it? Again, this is something that y'all gonna do later on. Run y'all studies, see if something is viable or not. Yeah, it's like science class. This is exactly what you do in science class, the scientific method and all that. This is it. All right. Yeah. Now, one issue to consider is whether to use the entire population in a study or a representative sample. If we use data from the entire population, we have what's called a census, right? So in a census, measurements or observations are from the entire population are used, right? So y'all know how we do the census every couple of years? That's what it is, right? We're getting information from the population, right? If we use data from only part of the population of interest, we have what's called a sample, right? Yeah, we got to build the vocabulary a little bit. All right. Well, this is still really interesting stuff. I feel like some of y'all like might have heard these words before. I know I did when I first heard them, but I never knew what they meant. Yeah, census. Really? So the government does a census I'm sorry, every year. Is it every year or every 2 years, something like that? They collect data on everybody, like how how much is your household income? What do you do for a living? Like what is your nationality, stuff like that. And then they collect this data for whatever they use it for, you know, probably taxes. Uh, right. Right. That's true. That's right. They use it for social work purposes too, right? Yeah. Yeah. Like benefits and things like that. Yeah. 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 Lovely government. All right, let's take a look what else we have. So in a sample, right, measurements or observations from a part of a population are used. All right, so samples come from a population. So experiments and observation. When gathering data for a statistical study, we want to distinguish between observational studies and experiments, right? There's a difference between them, right? So in an observational study, observations and measurements of individuals are conducted in a way that doesn't change the response or the variable being measured, right? So you're literally just viewing something, right? Like I want to see how many times a day does the puppy drink water? I don't know, right? Yeah. Like that's an observation. You're not influencing it or anything. You're just there looking and you're like, okay, that's one, that's two, you know? Let's take it up a notch, right? Let's say that you went to sports betting, right? Y'all shouldn't be sports betting, by the way, right? But you watching the sport, and every time they score a point, just make that dash like, all right, he got 10 points tonight. That's an observation, right? You're not you're not influencing the game, but you're keeping stats on the game, you know? Right. Exactly, exactly. Don't make bets. All right. Yeah. Yeah, yeah, yeah. No MGM, no DraftKings, none of that. Right. So, in an experiment, a treatment is deliberately imposed on the individual in order to observe a possible change in the response or the variable being measured, right? Easiest way to think of an experiment, think medication, right? So I'm giving medication to somebody and I want to see what's going to happen, right? Does their illness, whatever, go away, or does it enhance them or hurt them, etc., right? That's an experiment, right? So, right, you're influencing it. So observation, you're just looking at it. Experiment, you're doing something to see a reaction, and then record it. You know? So statistical experiments are commonly used to determine the effect of a treatment. However, the design of the experiment needs to control for other possible causes of the effects. For instance, in medical experiments, the placebo effect is the improvement or change that is the result of patients being just believing in the treatment, whether or not the treatment itself is effective, right? So let's say that I make a medication to, I don't know, cure AIDS, for example. I'm just making up something, right? So I would have two groups of people that both have AIDS, right? One of them I give the actual medication to, and the other group I'm gonna give them a sugar pill, right? Like basically like I'm giving them food basically. But I told them it's the medication, right? And then after viewing the observation, right, like looking at them, right? If my experimental group, the ones that got the actual medication, got better faster than the ones that I gave the sugar pill to, they just believed that they were getting the medication, then I know that the medication works. If there's no change, then I know the medication doesn't work. If the experiment group got worse, then I really messed up. Yeah. Yeah. So like a what? That is it. Yeah. Exactly. Exactly. Because we want to know if the medication really works or are people just believing that they're getting better. You know? Yeah. Sometimes, yeah.
Well, that's great.
Yeah. Yeah. Mhm. So the placebo effect occurs when a subject receives no treatment but incorrectly believes he or she is in fact receiving treatment and responds favorably, right? If they responded favorably from no treatment, that means they could literally just heal themselves in their head. That's crazy.
But no aid.
But could you imagine though? What if you just think health and just boom, you healthy? That's next level right there, yo.
They don't want to,
Yeah.
They don't.
Do you know how much money you would save? Like I'm healthy. Right? Mm-hmm. It's true, it's true. Oh yeah, soursop is a truth.
Yeah.
Yeah. Yeah, that's the truth right there. All right, so to account for the placebo effect, patients are divided into two groups. One group receives the prescribed treatment. The other group, called the control group, receives a dummy or placebo treatment that is disguised to look like the real treatment. Finally, after the treatment cycle, the medical condition of the patient in the treatment group is compared to that of the patient in the control group. A common way to assign patients to treatment and control groups is by using a random process. That is the essence of a completely randomized experiment, right? Of course, if it's your experiment and you have your loved one, you know which one you're putting them in, right?
I want to see something.
But technically speaking, scientifically speaking, statistically speaking, we shouldn't be doing that. But it is what it is. You know how it is. You got your loved one, you know.
Placebo effect will be working though.
It'd be what?
I think that would be working, like I
Yeah.
just game.
Mm-hmm. It does work. But can the medication work better? That's the question, you know?
What side effects of the medication?
That's another issue. That's why we have to have the control group. Because sometimes you take the medication and then all of a sudden you have side effects, you know? Yeah. Yeah. Right. All right. So a completely randomized experiment, actually, is one in which a random process is used to assign each individual to one of the treatments. All right. Two, two, two. Right. So, for example, can chest pain be relieved by drilling holes in the heart? For more than a decade, surgeons have been using a laser procedure to drill holes in the heart. Many patients report a lasting and dramatic decrease in angina, chest pain symptoms. Is the relief due to the procedure or is it a placebo effect? A recent research project at Lenox Hill, oh yeah, that's downtown anyway, provided some information about this issue by using a completely randomized experiment. The laser treatment was applied through a less invasive catheter laser process. So a group of 298 volunteers with severe untreatable chest pain were randomly assigned to get the laser or not. The patients were sedated but awake. They could hear the doctors discuss the laser procedure. Each patient, though he or she was receiving the treatment, right? Thought he or she was receiving the treatment. So the experimental design can be pictured as this, right? You have a patient with chest pain. They get randomly assigned to either one group that's going to get the actual treatment or one group that's not going to get the actual treatment, right? They go through the procedure and then you compare the pain relief, right? So the laser patients did well, but shockingly, the placebo group showed more improvement in pain relief. So the medical impact of the study are still being investigated. It'd be like that, yo. There is, yeah.
So like you don't have to.
So they randomly assigned it, and some people thought they got the treatment, and they're like, "Yeah, I feel better. Like this is amazing. Like doc, you the man." But they ain't get jack. You know, it is. It is.
Listen, if you stand,
Well,
we look. Yeah.
Lucy was a bomb. That was a good one. Yeah, go ahead. Simple sample. So how can I say this now? The population would be everybody that has this chest pain, right? But the sample is a 290 whatever people that volunteered to do this procedure, right? And then you broke them into two groups. Half of them got it, half of them didn't. And then you just compared and saw like, which was better. The people who got the procedure, people who did it. Yeah. All right, so it is difficult to control all the variables that might influence the response to a treatment. One way to control some of the variables is through blocking, right? So you could block what some people get or not. I'm gonna show you right now. That's the sample or the population, I should say. No, that's the population. People with chest pain, right? The sample would be the people that volunteered, right? And then the variable is the pain. Did it go away or did it still continue? You know? That yeah, yeah. The variable is what's changing, or what could change. That's the variable. You know? All right, so a block is a group of individuals sharing some common features that might affect the treatment, right? So, not a doctor, but let's say in this scenario, you wanted to test this treatment, but you didn't just accept everybody that has chest pain into this treatment. Like they had to have like severe chest pain. You could have even, yeah, you couldn't even went a step further. You could have said like, listen, like they got to be white, or they got to be black, for example. Like you could have went extreme like that, right? So that would be like you're blocking it to a certain group, and then you're testing it, you know. And so in a randomized block experiment, individuals are first sorted into blocks, and then a random process is used to assign each individual in the block to one of the treatments. All right. So let's take a look at one. Yeah, let's take a look at one. So a randomized block design utilizes gender for blocks in the experiment involving the laser holes for the heart, right? So you have the patients that have severe chest pain, right? So then now we're gonna break them first into like men and women, right? Men go one way, women go another way, right? Then you apply the random sample thing to them, right? One group is gonna get the treatment, one group is not, right? After that. And then you compare the two pain reliefs, right? So when you're comparing them, you're comparing men with men women with women, right? So, right.
And then that's how people do it further on. Oh,
Yeah.
men suffer more than this and certain stuff than women.
Right.
Or like the race.
Yeah.
They say like Asian,
Yeah.
they're higher, they suffer more from liver and stuff like that.
Could be.
That's what it adds to.
Yeah. That sake is real.
Your genes too, yeah, but
Mhm.
it's crazy, like race does play a part. It's where you live, like, you know,
Definitely.
it plays a role in your health. You could live high in the mountain,
Yeah,
yeah.
like there's a lot of
It's
people.
not the same. I
that-
like what I've done.
That's why like all the like the marathon runners, like the ones that come from Africa, like they got the ill like advantage, yo.
They-
The stamina is crazy.
They're where they live at like such a high elevation that they don't have access to as much oxygen as we have. So when they run the New York City Marathon in New York City, they got mad oxygen, so it's light. Yeah. That's why they finished the race in 1 hour. It's like, where's everybody?
What is it, stronger? You don't have less
Yeah.
blood there.
Depending, yeah.
Yeah.
Like, speeches, speeches, all of that stuff.
Like if you go to Colorado, right? Like you'll notice that you'll be like slower in Colorado because you're at such a high elevation compared to New York. But someone who comes from Colorado to New York, they just have energy because we have more oxygen than they do. Mhm. Yeah. Yeah. It's interesting. All right, so there's a control group, right? This group receives a dummy treatment, enabling the researchers to control for the placebo effect. In general, a control group is used to account for the influence of other known or unknown variables that might be an underlying cause of a change in response to in the experimental group. Such variables are called lurking or confounding variables. All right. Randomization is used to assign individuals to the two treatment groups. So this helps prevent bias in selecting members for each group. Replication of the experiment on many patients reduces the possibility that the differences in pain relief for the two groups occurred by chance alone. All right. So, So many experiments are also double blind, right? This means that neither the individual in the study nor the observers know which subjects are receiving the treatment. Double blind experiments help control for subtle biases that a doctor might pass on to a patient, right? God no, if I was a doctor, all my patients getting the treatment. I don't care, right? But if you my coworker and you giving me a patient, like, yeah, all right. That's an experiment. You gonna get that sugar pill. My patience. Oh man. Mhm. All right, yeah, go ahead.
Okay, so,
Mhm.
Yeah, let me show you. I don't know if it's a glitch in the system. So look.
Look,
I
it's right.
put
Good
a
job.
Positive 1,000.
Mhm.
No, why didn't that cancel out into a positive?
Because it's to the third power. So it's -10 times -10 times -10.
So if it's to the second power, it does cancel out.
Yeah,
If
that's
it's to the-
positive.
Okay, so if it's past the second power, it's gonna be
If
negative.
it's odd, it's negative. If it's even, it's positive. Yeah. Yeah.
If I went without Google.
Good job. I'm impressed.
Oh, thanks.
Impressed. Yeah. All right, so let's talk about surveys. It's going to be interesting, right? So once you decide whether you're going to use sampling, census, observation, or experiments, a common means to gather data about people is to ask them questions. This process is in essence of surveying, right? Sometimes the possible responses are simply yes or no. Other times the respondents choose a number on a scale that represents their feelings, right? From say strongly disagree to strongly agree. Such a scale is called a Likert scale, right? In the case of an open-ended discussion type response, The researcher might determine a way to convert the response to a category or a number. A number of issues can arise when using a survey. All right, let's talk about that. We're going to talk about some of the pitfalls of using a survey. I hear you can get paid to do surveys online too, so that's another side hustle. I gotta look it up, but I heard about it. I heard about it. So some potential pitfalls of a survey, right? Non-response. So you have individuals that cannot be contacted or refuse to participate. So non-response can result in significant undercoverage of a population. Then you have the truthfulness of the response. Respondents may lie intentionally or inadvertently. That's another thing, right? It's true, right? Then you have faculty recall, right? Say they got to recall the information from like 10 years ago, right? Respondents may not accurately remember when or whether an event took place, right? Then you got hidden bias, right? The question may be worded in such a way as to elect a specific response. The order of questions might lead to biased responses. Also, the number of responses on a Likert scale may force respondents that do not reflect the respondent's feelings or experience, right? So say I'm taking a survey, right? The first 5 questions was lit, but then I noticed that wait, I have 200 more questions to go. Oh, that's it, right? Then you got vague wording such as often, seldom, occasionally, meaning different things to different people. You know, you have interviewer influence, right? This is the FBI right here and the CIA. This is them right here. Factors such as the tone of voice, body language, the dress, the gender, the authority, and ethnicity of the interviewer might influence responses, right? Like, have you ever seen the police be like, "I know you was there and you committed a crime," and you're like, "I wasn't." They're like, "No, I know you was there." Hey, that's that right there, right? Yeah, they're trying to influence you, right? You know. Then you have voluntary response, right? So individuals with strong feelings about the subject are more likely than others to respond. So such a study is interesting, but not reflective of the population, right? So like, yo, I know I ordered, right? My coffee with cream and 2 shots of espresso and it didn't come. I'm leaving a survey right now. Like, you know, they done left out one of the shots. I said 2 shots of espresso, just like that. Right. There's some real stuff right here. Y'all got your computers, y'all could be knocking out the homework too. Yeah. You interested? I got you. I like that too. All right. So sometimes our goal is to understand the cause and effect relationships between two or more variables. Such studies can be complicated by lurking variables or confounding variables. So a lurking variable is one for which no data have been collected, but that nevertheless has influence on the variables in the study. So two variables are confounded when the effects of one cannot be distinguished from the effects of the other. Confounding variables may be part of the study or they may be outside lurking variables. For instance, consider a study involving just 2 variables, the amount of gasoline used to commute to work and time to commute to work. Level of traffic congestion is likely a lurking variable that increases both of the study variables. In a study involving several variables, such as grade point average, difficulty of courses, IQ, and availability, study time, some of the variables might be confounded. For instance, students with less time might opt for easier courses, right? Some researchers want to generalize their findings, to a situation of wider scope than that of the actual data setting, right? The true scope of a new discovery must be determined by repeated studies in various real-world settings. Statistical experiments showing that a drug had a certain effect on a collection of laboratory rats do not guarantee that the drug will have a similar effect on a herd of wild horses in Montana, for example. Right? So one medication might not work for everybody. It'd be like that. Right, so the sponsorship of a study is another area of concern. Subtle bias may be introduced. For instance, if a pharmaceutical company is paying freelance researchers to work on a study, the researchers may dismiss rare negative findings about a drug or a treatment. Mhm. So choosing data collection techniques. We've briefly discussed three common techniques for gathering data: observational studies, experiments, and surveys. Which technique is best? The answer depends on the number of variables of interest and the level of confidence needed regarding statements of relationship among the variables. Surveys may be the best choice for gathering information across a wide range of many variables. Many questions can be included in a survey. However, great care must be taken in the construction of a survey instrument and in the administration of the survey. Non-response and other issues discussed earlier can introduce bias into a survey.
Yeah, like you said.
Right. Mhm.
Ignoring
Exactly.
all the time.
Mhm. Exactly. Mhm.
So cool.
Mhm.
I just realized that I could take pictures of this
Yeah.
and then copy and paste the
Mhm.
notes from the actual photo and put it like in the notes on my phone.
That's true.
And I was here
That's
killing
true.
my poor arm writing.
Writing
all this
it?
down by
Got
hand.
you. Then you even got injured too?
No, your mom is like really fucked up.
Oh, wow. Yo, the writing is real. Yeah. Got you. Got you. All right. Dang. Got you. All right. So look, observational studies, right, are the next most convenient technique for gathering information on many variables. Protocols for taking measurements or recording observations need to be specified carefully. Experiments are the most stringent, right, and restrictive data gathering technique. They can be time consuming, expensive, and difficult to administer. In experiments, the goal is often to study the effects of changing only one variable at a time. Because of the requirements, the number of variables may be more limited. Experiments must be designed carefully to ensure that the resulting data are relevant to the research questions. All right. Good stuff. Good stuff.
This is
Hmm? What do you mean? It's gonna be on YouTube, something like that. Mhm. Looking when you look at the in the announcements, those blue words, that's the links.
Okay.
Yeah.
I thought you were doing right beside.
Yeah, it's already posted.
Oh.
Yeah. Yeah. I was late in posting though. I just posted something today. So yeah. Yeah. But look at the announcement for today. All right, special note, right? An experiment is the best technique for reaching valid conclusions by carefully controlling for all other variables. The effect of changing one variable in a treatment group and comparing it to the control group yields results carrying high confidence. So the next most important effective technique for obtaining results that have high confidence is the use of observational studies. Care must be taken that the act of observation does not change the behavior being measured or observed, right? So if you're observing something, right, you don't intervene, right? Yes, that lion is going to eat the gazelle. I know it hurts, right? But you must not intervene. We're trying to observe it, right? That's how that goes. The least effective technique for drawing conclusions is a survey. Surveys have many pitfalls and by their name cannot give exceedingly precise results. A medical study utilizes a survey asking patients if they feel better after taking a specific drug, gives some information but not precise information about the drug's effects. However, surveys are widely used to gauge attitudes, gather demographic information, study social and political trends, and so on. All right. All right. So important features of a data collection plan. A data collection plan identifies the population, the variable or variables, whether the data are observational or experimental, whether there is a control group, use of placebos, double-blind experiment, etc. The sampling technique to be used, including whether a block design is to be used, the method used to collect the data for the variables survey, method of measurement count, etc. Right? Let's talk about ethics. So ethics and statistics, right? Why are ethics important in statistics? So there are many reasons that ethics in statistics is important, such as the discovery of useful knowledge, truth, avoidance of errors, prohibition against fabrication, trust, and accountability to the public. All these support constructive social values and help build public support. All right. So you don't want people like gathering your data to use it against you, that kind of thing. Right? Let's elaborate on ethics just a little bit. All right, so ethical practice and statistical requirements. Transparent and openly stated assumptions regarding data collection and statistical methods used, right? So these are the ethical practices and statistical requirements. Advancement of useful knowledge while avoiding harm to others, especially subjects under the study, right? Avoidance of all prejudice and conflict of interest or favoritism in sampling methods so that the results extend beyond the sample to the specified population. Respect for intellectual property and privacy of others while observing all confidentiality requirements, right? Reproductile, right? Results within expected deviations and valid interpretation of outcomes, recognition that results of valid statistical studies may or may not conform to the expectation or desire of these commissioning the study. Because society depends on informed judgments from statistical methods, ethical guidelines should be in place describing statistical results and methods. In short, the practice of statistics requires professional integrity and accountability on the part of anyone using statistics, right? Finally, any misconduct or attempted misconduct or unethical practices cannot be condoned or even appear to be condoned. Rather, these must be reported for investigation following prescribed procedure. All right. So be truthful. Basically, that's what that's saying. All right. Hmm? Yeah. 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 All of that. Yeah.
He said he broke it down.
You'll see everything. Everything.
Should I actually,
Mhm.
like, my notes, like the
Yeah.
exact.
Yeah.
Graduation,
Yeah. It'll help you with the homework. Yeah.
graduation,
Yeah.
and
Mhm.
you gotta figure out what's what.
Definitions. You'll see. It's not that bad.
Mhm.
Yeah. Yeah.
Very good.
All right. Have a great weekend.
Sign.
Oh, yeah, I forgot about that. Sick.
Oh my God, I hope she's not crying. I'm gonna let you know if she didn't wanna leave. Like, I did leave. No, cause she said bye to me from tomorrow.
Would we? Say find it. I'll write the stuff on there later. All right. So for next time, right? Huh?
Sticking like
Yeah.
this, cause I'm not really like on it, cause it's like it's not really like numbers.
Yeah.
But the numbers, like we do this, I'm getting it. When I was actually the GCD, not LCD, that's when you do division first, right?
Right. Well, that's whenever you have to add or subtract, you have to get the same denominator.
Oh, addition and subtraction.
Right.
GCD.
Yeah.
Multiplication and division of LCD.
Right.
Okay.
Yeah.
What video should be I'm trying to look like I'm leaving like a classroom.
It's in the announcement. Yeah, the blue words in the announcements, that's the links.
Oh, okay.
Yeah. You can access it on your phone, on your computer, anything. All right, next time we meet, frequency tables, all right?
Frequency, what?
Yeah. But if y'all wanna try it for homework, go ahead.
This is all I have to do it.
Okay.
Look, I put the homework.
Wait, hold on. Let me just stop this real quick.
Oh, it was recording.
Nah, you fine, you fine.